Hello, welcome to another briefing. So this is going to be quite a long briefing because I have a lot of things to go over. Um, so we're going to start out here with the satellite image. I want to show, first thing I want to show is this big swath of moisture we have that's it's coming off the Pacific, going into parts of Northern California, even into Nevada and Idaho. And this is what was responsible for the copious amounts of rain that we've had over particularly Northern California over the last few days. And there was some rain that did sag south into the Bay Area as well. I'm going to go ahead and show what the radar looked like in the last 36 hours or so. So this is going back to this would be Sunday night, as most of that rain was over Sonoma County in the north central valley into the Sierra, and then Monday morning we had a pretty heavy band of moderate to heavy rain over San Francisco and the East Bay and parts of South Marin, including where I'm located. Over an inch, almost an inch and a half, roughly, of rain at my house, and um, just all of that fell really within 12 hours, really by noon, from midnight to noon, really. And so, but you can really see when we talk about atmospheric river and meteorology, this is what we mean. We mean this narrow hose of moisture extending all the way from the tropics out near Hawaii into California and even Nevada and Idaho, and this thing can go many ways. It can sort of wobble back and forth, sort of like a hose. If you're pointing a hose somewhere and then you let go of the hose and it just wobbles, this is what atmospheric rivers do, and this is why they can produce copious amounts of rain in one location, and then you go maybe just a few miles north or south and there's pretty much no rain. It's a very narrow band of concentrated moisture that comes together with lift, and then it goes up over mountain ranges, what we call orographic forcing, where a mountain range or a hill will squeeze out more rain out of these clouds, because you're taking air up the mountain, and you're that facilitates convection, and you end up squeezing more rain out of it. So that's what we had going on the last few days. Really, it was really concentrated north from Sonoma County north. Really, we had a few showers in the Bay Area, and then yesterday morning we had a really solid line of rain, and a little bit of wind with that. Not as much wind as we're supposed to see tonight. But yeah, we have pretty good rain for some areas. Although if you go south of San Mateo, roughly into San Jose, Gilroy, Monterey, there's been really not much at all so far. But that should change. And so what we're seeing now is this sort of hose of moisture starting to shift further north, and that is setting the stage for this strong surface low to right up the coast, and that's going to bring a lot of wind and eventually more rain, as well as a cold front associated with that sweeps through. I'm going to show roughly where this low is developing, way off the coast still to our southwest, but it is rapidly strengthening, rapidly intensifying. You have a lot of cold air behind the system. You see these puffy, like cumulus type clouds. That indicates that you have a lot of cold air in the upper atmosphere. You have cold air aloft, essentially, with warmer air at the surface, especially with warmer than normal sea surface temperatures in this region. You have a lot of warm air at the surface. You have a lot of cold air aloft. That creates a lot of instability, a lot of negative buoyancy, where air parcels are being they are rising from the surface to the upper levels, and they're just there's a lot of upward motion in the atmosphere when you have a lot of instability, when you have cold air aloft like this. And this is also starting to slowly push this over here. It's digging basically a deeper trough here. This colder air pushes in, and this trough over here gets deeper. And then you have, in turn, I'm going to try to not get too technical, but when you have on the downstream of the trough, when you have a sharp trough like this, you get a lot of divergence downstream of the trough. It means that the air is kind of spreading out at the upper levels, and when the air is spreading out at the upper levels, you lose mass in the air column, and that in turn causes rising air at the surface, because the air is at the surface is filling in, trying to compensate for that loss in mass aloft, and that's when you have the formation of a surface low like this. And then, because the winds aloft are they're going southwest to northeast along the edge of this trough, that's where the surface low here is going to be steered. It's going to be steered up here, and then it skirts right by the coast of California. And we're going to look at that in the computer models. And you'll see what I mean really with this. And this is going to bring a lot of wind and some rain as well, because it's going to be attached to a cold front. So let's go ahead and move on to the next couple things I wanted to show. So I want to show you briefly here the surface map. This is surface analysis for 4 a.m. and we're seeing basically surface lows and seeing surface highs here. You can see that surface low I was talking about. It's already 1,008 millibars, and it's deepening, so it's getting lower here. This pressure. Well, I did not realize, but there are a few stations that are taking pressure out over the ocean. This is 996. Oh no, sorry. That's 1,009 millibars. This would be 1,010. This would be. I mean, it's dropping. It's dropping. I'm estimated 1,008 over here, and that's going to continue dropping. This is what's going to ride up the coast and give us a lot of wind. Now, I won't get too into this, or this video is going to be super long. It's already long as is. So let's move on here. This is just basically showing maximum wind gusts. This is showing temperature and wind. Still not a lot, although we're starting to pick up some wind up in the mountains, up in the hills here. Got a 30, gusting 31 already at Pine Mountain Fire Road, 1,700 feet, just west of San Rafael, roughly. And if I'm gonna go ahead and put the historical wind here, so you can see the last major wind event that I think will be comparable to this one was February 4th of 2024. And if we put maximum wind gust here, you can see how incredibly strong and in many cases damaging these winds were. We have here 81 miles per hour at Wolfback Ridge. This is pretty close to where I live. It's up in the hills, but I mean, that's pretty close. That's, I think, a mile, roughly. I live roughly around here. So, it's pretty close to where I am. And I remember that day was very windy. It wasn't 81 at my house, but it was up in the mountains, up in the hills. It's only really 1,000 feet up at the station. I had an 81 mile per hour gust there, 54 at Ocean Beach, 51 at downtown San Francisco, out by Pier 1, 51 in Potrero Hill, 60 at Oakland Airport over here. 62 here in Mill Valley, 54 in Mount Tamalpais, 96. There was actually a 100 mile per hour gust further north. If I just put this over here, yeah, 102 over here, just southwest of Novato up in the mountains. Nicasio Hills, 937 feet. They had a gust to 102 on that day. And there were a lot of gusts in the 30s and 40s in the lower elevations and right by the water, even 40s and 50s widespread here. Now I'm gonna go ahead and show. You know what? I'm gonna change the order of this briefing a little bit because it'll just make more sense this way. So I'm gonna go ahead and show you now the projected winds. I'm gonna use a few different models here. Let's start out with the HRRR, High Resolution Rapid Refresh. And this updates every hour, so that's kind of good. And this is a longer run from 12Z. And so as we go through, let's start out. So this is accumulated maximum gust. We can put this into motion here as we go through 9 a.m., 10, 11, noon. So even at noon today, we're expecting already widespread gusts into the 20s and some 30s and higher already in the coastal areas. And then as we go throughout the day into 7 p.m., you're looking at already 40s, maybe some 50 mile per hour gusts or more along the coastline. And then you go in to 11 a.m. and then overnight, 11 p.m., overnight into 4 a.m., potentially 55 mile per hour gusts in Half Moon Bay. Now, from what I've seen, this can be underdone sometimes. So it could be even stronger than that. But we're looking at widespread gusts in the 40s, almost 50 mile per hour at Oakland Airport. But that would be not too far off from what we had on February 4th of last year. Probably not going to get to where they were then, but it's going to be pretty close. And depending on what track this low takes, it could vary. I mean, the models have been kind of wobbling back and forth on this. If I go ahead and put the NAM model, you're going to see that's even stronger. Now, the NAM tends to be a little overdone with wind, so do take it with a grain of salt, but still, like, compare this to the run before, and see, there's some changes. Do this instead here. So the current run 49 hours. So you look at the previous run. Oh, so I guess this is all it goes out to. Oh, so this is Thursday. Okay, wait. 4 a.m. Wednesday. Okay, here. So look at previous run and then this run. See, the previous run was even stronger. And then it backed off a little bit in this latest run. And so it's been kind of back and forth, the track of this. So there's the previous run. There's the run before that. See how it kind of like, there's fluctuation because the track of the low pressure, it is varying a little bit. See, just do it from here. See, it changes. So let me show you the pressure, and I'll show you kind of what I mean here. So here's that 8 p.m. Tuesday, have a 988 millibar low, and it's still strengthening as it moves up the coast here. But for this latest, okay, for the 6Z NAM, it has it 9 p.m. Tuesday. It has it basically right off of the Bay Area. The latest run has it a little further south. The run before that had it a little further north than that, but further south than the 6Z. So it's just been wobbling. The models have a hard time sometimes with pinpointing the exact location of the surface low, and the exact location of the surface low is going to have a big impact on who gets the most wind, what direction the wind is going to be. So in this solution, the most wind would be right here, roughly. With this solution, probably going to be focused further south. So if I go ahead and just put back to wind, see the strongest winds are right around the edges of that low. So in this case, it's over here. But if you put the different run here, it's further south, like I said. It's really going to depend on where this sets up. But regardless of where exactly it sets up, we're looking at pretty strong winds for the Bay Area particularly. Let's go back so I can be more zoomed in. And then let's compare this to something like the NDFD. It's yet another model. And so there's fluctuation here. So this is going into 4 a.m. Wednesday, maximum gust. See, the NAM is generally more aggressive. Actually, you know what? Let me compare it to her, because the NAM kind of has a bias towards being kind of aggressive with winds. So let's go to the her. And we'll go 4 a.m. Wednesday, Pacific time. Compare that to the NDFD, for instance. So, I mean, it's similar. You have mostly agreement, but you have some differences here. You have the her wants 55 for gust in Half Moon Bay. The NDFD is going 62. The her is mostly 40s for the East Bay shoreline, like 49 Oakland Airport. This model NDFD wants 52. That would come closer to what we actually had on February 4th, which was 60 at Oakland Airport. If I go back here, you can see that 60 at Oakland Airport right over here. That's what we had February 4th of last year. And yeah, so and then it has the NDFD seems a little bit stronger than the her. Not like it's not as strong as the NAM, but it's a little stronger than the her. Let's take a look at the national blend of models. Actually, let's look at, see, there's two of them, and one of them is more improved. So let's look at this one. This is like the latest version of the national blend of models, which is a bit more improved compared to the previous. And you're still looking at really strong winds. This basically takes a blend of all the model guidance out there, kind of makes an average of it. And we're looking at, I mean, maybe not as strong as the NAM or the NDFD, but this is pretty powerful. 56 mile per hour gust in Half Moon Bay. That's enough for widespread power outages, down trees. Like, we have to be aware. If you're driving out there, you got to be careful. There's a lot to be careful. This is nothing to scoff at. These wind values here. It might not reach the levels we had with that storm last year in February, but I mean, this is nothing to scoff at. This is widespread gusts over 40 into 50, even more. I would expect probably, I hate to say it, but even 60, 70, maybe higher for areas like Wolfback Ridge, like had that 81 mile per hour gust last year. It could be there could be really strong wind along the coast. There could be really strong wind along the coastal hills here, and even some of the mountains like Diablo, some of the Santa Cruz Mountains, Mount St. Helena, Mount Hamilton down here. We're looking at, no matter how you slice it, no matter what model you look at, there are some differences in there in terms of the strength and everything, but we're looking at a pretty windy period. And it's interesting to notice here, you can see at the same time as you see areas that are going to get a lot of wind funneling and very strong winds because of that funneling, you're going to have areas that are wind shadowed because, like, you have mountain ranges here. So this is going to be a predominantly south wind. Okay. And so when you have mountain ranges like in the Sonoma Valley and the Napa Valley here, these are mountains. That's why you have a lot less wind here. Like I think this is the Napa Valley, for instance. You're gonna have some areas here. If we just look at the, apologies for that sound. It does that when I try to move the screen sometimes after I'm using the tools. You're gonna have maybe only 20 miles per hour or so for a gust in some of these areas, whereas just a few miles away you could have 40 or 50 because you get wind shadowing. At the same time as you get wind funneling in some areas, you get the wind ends up shadowed in other areas because of terrain. Same thing with rain. Now I'm going to show rain because I've been talking about wind for a while now. So that's a general picture on the wind. Now I'm going to go ahead and talk about terrain. Sorry, I'm going to go talk about rain. So let's look at the national blend of models because it's kind of like one blend of all the models. It's easier than spending hours or minutes on end looking at different models. We're going to kind of try to simplify things a bit. So let's look at composite reflectivity, which is basically simulated radar. And this is what we're supposed to be looking at rain-wise. I mean, you're going to see dry most of the day, and then in the evening, 4, 5, 6, 7 p.m., you start to see some showers, start to see some moderate to heavier bands of rain move through. And then that's with really strong wind. Like the core of this storm looks like to 9 p.m. to about 1 a.m. And then 4 a.m. there could still be some winds blowing. And then that ejects. If you look at let's look at the HRRR model, which tends to be a little more granular. Sometimes it's nice to look at that too. I mean, this has something similar, dry most of Tuesday, and then evening you get some showers. It's a little more scattered. And then you have some heavier downpours that start to really make it pretty much Bay Area wide, making their way in around midnight or so. And then that pushes out, and we have another wave of showers, and then some pretty strong wind potentially as well on Wednesday night here. So I'm gonna go back to wind gusts. Let's just do instant gusts. I mean, not as strong. Well, a few runs ago, this was looking not as strong as the run before. Now, for some areas, this looks a little stronger. Got 71 in Half Moon Bay on this thing. Let me go put gust swath. Because if you go back to the first round, early Wednesday, you're at 55 for Half Moon Bay, mostly 40s over here. And it actually does get a little bit stronger. Goes maybe even close to 50 for somewhere like Novato with potentially 71 in Half Moon Bay. Now, you can't trust any deterministic model run to be absolutely correct. Like, there's no guarantee that any one solution is what's going to play out, but you're just getting the idea here of how bad this can be. And let me go back to let's compare to the NDFD real quick. I mean, not as strong as the HRRR, but still pretty strong. Go back to instant gusts because I don't want to conflate. I mean, yeah, not as strong, but this is still very significant. Both Tuesday night and Wednesday night look very windy, and I would say there's a risk of power outages for both nights. Like, Tuesday system, sorry, the Tuesday night system comes through. So Yeah, so this is like 1 a.m. Wednesday morning. And then it actually relaxes a little bit. Don't be fooled, because there's more. You go into about 4 p.m. Wednesday, it starts ramping up again. And then look at that. That's another pretty strong wind event. Something to watch for sure. I'll just put the national blend of models for the heck of it. And I mean, even on the national blend of models, it's looking pretty strong too. This is looking actually at least equally as strong now. Maybe stronger for Wednesday night for some places. Like, this is actually pretty impressive to me, because just 1 or 2 days ago, it was looking like Tuesday was going to be the stronger wind, and now they might even be like both. Like, Wednesday could be at least just as bad, so that's pretty impressive. I'm gonna go ahead and show you the European model now. And this has been showing this deep low, mind you, since December 12th. I was looking at this model way back on the 12th. It was starting to show. I mean, of course, different locations and trajectory, but some sort of deep low was already showing up as far back as the 12th. So the computer models can really pick up on this stuff well in advance. This for instance, was picking up on it up to like 2 weeks ago. So I just want to show you kind of the long-term pattern as we go through. I know this is a really long video already. You don't need to stay if you don't want to. I'm gonna wrap this up real quick now. But I just wanted to show the general big picture for the next week or so, and I'll take it with a grain of salt. This could change, but here's that first wave, Tuesday night into Wednesday, and then here's Wednesday, Christmas Eve here, into Thursday morning, Christmas morning. You have a colder wave. This would be some lower snow levels and pretty good precipitation for most of California. And you really see that snow really starting to show up, more blues than greens now into the Sierra and then into the Intermountain West. The Thursday, Friday, Saturday will be much colder precipitation. And then it starts to dry out, but it'll be pretty chilly. And then some moderation of the air mass, some light warming. I wouldn't call it warming, really. Just drying out, a little more comfortable, a little more pleasant. And then we get potentially another system January 3rd, and then could get some more cold systems after that. This is way into fantasy land. Take it with a grain of salt. I don't know if this is going to verify, but this would be another nasty windstorm for Northern California if that verifies with an even stronger low pressure off the coast. But take it with a grain of salt. We're looking way out there. This is just a different visualization, a little more zoomed out than what I was looking at. But you can really see what I was showing earlier in the video with the satellite. Here's that first mid-latitude cyclone, surface low, riding up the trough. This is the trough I was talking about. And then here's another one. Here's the one behind it. That's wave number 2 that comes in Wednesday night. And then there's even wave number 3 out here. Now I put this into motion, you'll be able to see. There goes wave 1. Right, there's wave 2 into the Bay Area. Much colder because you're more embedded in that colder air. You see these blue thickness lines, these blue lines here, that's the colder air aloft starting to come in. And so this wave is in the cold sector. See, when you go from blue to red here, that's the barrier in between cold and warm. And this system here is in the cold sector. If we go back, you'll notice system number 1, it's in the warm sector. Higher snow levels, generally warmer or milder air mass. And then this one, much lower snow levels, colder air mass, cold and wet pattern. And that pushes through even into early Saturday morning. We could still have some leftover showers. And then it looks like Saturday, Sunday, Monday drying out nicely into next week, and then potentially around the 3rd we have that next system. So I know this is an extremely long briefing, probably one of the longest briefings I've done in a while. So I'll leave you with that for today. But I hope you were able to get something out of this. I hope you enjoyed it. I hope it was helpful. Thank you for watching, and I'll see you next time.